Okay, so from yesterday, is there anything that you would like to go over? Because we had mentioned that the organic portion began on page 711. So let me point this out to you on on about, or I shouldn't say on about, it is on this page 719. When we talked about iron and tin and lead yesterday, why did we put those three elements up on the board? Because we, I know Fe stands for iron, I know Pb stands for lead, and I know Sn stands for tin. But those are the English translation names because they actually come from Latin. So what does that mean? Yeah, it means translation, but they're actually derived from them. So it means that's where they come from. The ferrous, the plumbum, and the stannate. Okay? So on page 719, what is that telling you on table 4 on the very top? Alkyl groups. Okay? So if, like we said yesterday, CH4, that is what? Methane. Then you go straight across in the column to the alkyl group. So what do you notice in the upper right hand corner then? That's a methyl group. Okay, so however many carbons are associated with that, all the way up to 4, although we're not going to discuss that this year, but we could. If you had C4H9, what would that be called? Not butane, no, C4H9, butyl group. Okay, so with that, do we understand why it goes from methane to methyl, ethane to ethyl? Because that's what they're derived from. Okay, one of the aspects um, that I don't agree with is if you turn back about 3 pages on page 713 in big red letters, what is that about? Okay, we don't talk about isomers yet. We could, but it's, I don't know. You're going to have to at some point. I don't know, because we have learned it before 2 years ago. You knew isomers means you have the same molecular formula, but just a different structure. That's all that means. But we'll leave that for a later time. Another aspect is if you turn the page on 714, they start talking about cis and trans compounds. Should we start diving into that? 714. Should we talk about them? Those are alkenes. We haven't even talked about alkenes yet. Well, if there must be a logical reason that it's in this order, right? Okay. But that doesn't mean we need to talk about it, does it? Okay, fair enough. All right. So then when you look at the very first section on page 716, that's how we started the chapter, just talking about hydrocarbons. Okay? So that's not the first time you've heard the term hydrocarbons. We discussed it last semester. We applied it in balancing chemical reactions. How did we do that? What type of reaction? Was it a single replacement? Was it a double replacement? Was it a synthesis? Was it a combustion or a decomposition? Okay, it was a combustion reaction because you have what on the reactant side? That's on the right side. Yeah, methane, which is a hydrocarbon. Yeah, hydrogen and carbon. Okay, so that's where that term came from when we talked about combustion reaction, just carbon and hydrogen. Okay, now We're not ready to start talking about different types of families yet. Okay? We have in physical science, but we've been discussing organic compounds for probably a little over 2 weeks now. So, again, one of the things that we tried to point out to you is the older you get in a curriculum or when you go off to college, you're going to go a lot faster. That's, I don't make the policy there. That's just what will happen when you move off and go to a post-secondary institution, okay? So, if you're looking up at the board, okay, is there anything confusing about that?
Wait, is that CH3 on top or is that methyl?
That's CH3. You could probably see that if we had the rest of the lights on, but we chose not to.
Well, it just looks connected.
Okay. All right. Okay. So, is there a different way you can write these methyl groups? Yes.
Yes.
Just like that. That's a methyl group.
Oh.
That's a methyl group, CH3. This is a molecular formula where that's a structural
So
type.
these two are the same thing, just different order?
No.
No, never mind.
No. Okay. So, again, when we start naming these compounds, we read what the author says, what the policy, or not the policy, but the rules are for naming these. We said we can approach this one of two ways. We can just tell you how to do it, which makes more sense, or you can read what the actual rules state, which makes it really, really confusing. Okay? But we decided to read out of the book. Okay? But to keep things short, okay, what is the first thing that you should do in naming a hydrocarbon compound like that? Find the longest continuous chain. Okay? So, written in the brown, okay, what would that possibly be? Because it doesn't necessarily always going to be a straight line. Say that again. Okay, maybe. Does anyone else think they know what it could possibly be for a parent chain? Okay.
Say like what you have.
No, not yet. The parent chain is octane. Okay, that is correct. We do have this. Okay. So now, is there anything branching off of that octane? Yes. So as we approach this, does it maybe go straight like this, or does it maybe go up and over? Yeah, it can go either way. Okay? Because if we go 1, 2, 3, 4, 5, 6, 7, 8, you can also go 1, 2, 3, 4, 5, 6, 7, 8. So that's how we arrive at octane. Have you blinked yet? Okay, looks like you're in a trance or something. Okay? So now we've established our parent chain. Is there anything branching off of that parent chain? The answer is yes. So let's say X marks the spot. Okay? So let's keep it simple and just say it goes like this rather than up and over. But you could. So there's a derivative on this carbon, on this one, and this one. Okay? So what are the derivatives that are branching off of this parent chain?
Methyl and
Okay, there's an ethyl group and 2 methyl groups. Okay, so we have to account for all 3 of them. So now, is this going to go left to right or right to left? Are we sure? Yes, it does. Because if we do left to right, we got branching off of 3, 4, and 5. If we go this way, we got 4, 5, and 6. So it has to be going this way. All right?
Wait, so it's never mind.
Okay? So now, okay, so there's nothing wrong with doing this, putting an E here. Okay? So you know that this is an ethyl group that branches off of that. We know there's a methyl group here and a methyl group there. Okay? So, with that, not only do you have to find the lowest combinations, but once you've done that, they have to be placed in what order? They have to be in place in alphabetical order. But there are exceptions. Exceptions to the rule would be the prefixes that you use, because how do you denote two methyl groups? Dimethyl, and the numbers that they're associated with. So when we talk about dimethyl, okay, and we've got an ethyl group, okay, so which one of these two terms is going to come first? Are we sure? What are some exceptions to the rule? No. Okay. We only read about it yesterday, I believe. Okay. So, and we verbally said what there's exceptions to the rule are. Okay. So, in rule number 2, like what we had read yesterday, okay, rule number 1 was find the parent chain. We've done that. Rule number 2, add the names of the alkyl groups. We've said what they are. Okay, this is on page 721. It says add the names of the alkyl groups in the front and the name of the parent hydrocarbon in alphabetical order. Okay, we haven't quite done that yet. When there is more than one branch of the same alkyl group present, attach the appropriate numerical prefix to the name di, tri, tetra, and so on. Do so after the names have been put in alphabetical order. Okay, number 3. Okay, if one or more alkyl groups are present, number the carbon atoms in the continuous chain to give the lowest numbers possible in the name. If there are two equivalent lowest positions with two different alkyl groups, give the lowest possible number to the alkyl group that comes first in the name. This will be the alkyl group that is the first in alphabetical order before any prefixes are attached. Did I read that too fast, or?
No, I was just trying to follow.
Okay. And then rule number 4, put the positions and numbers in each alkyl group in front of the name of that alkyl group. And rule number 5, use hyphens to separate the position of numbers from the names. If there are more than one number in front of the name, use commas to separate the numbers. One of the aspects that I thought said in these rules, it does not, but it should, is that prefixes are disregarded. So we're going to keep things consistent. So
Oh, it says this will be the alcohol group that is first in alphabetical order before any prefixes are attached.
okay. So it's how you read. Okay, so that means that you disregard the di, the tri, all of that.
So it's 3, 4, 5.
So what that means then, you disregard this and you go by these two letters. Okay? So you disregard the prefixes. Okay? So now our ethyl group is located on number 3. Okay? So we've got 3. Now this is the hard part, trying to establish how much room you actually need. It's always going to be more than what you think, probably. Okay? So we've got 3 dash ethyl dash what?
Dash 4, 5, 6.
comma 5 dash like I said, it's always going to be more than what you think. Dimethyl octane. Okay? So now, what I want you to do is look at, what do you notice about page 719?
Wait, which one? Oh,
It's something very similar, isn't it? Okay? The only thing that is different, okay, is what's missing on that example of the book, or excuse me, what's missing on here that the book has an example. There's what right here? There's another methyl group. Doesn't it say 3-ethyl? 3-ethyl, 2, 4, 5 trimethyl octane. Okay. Now, one of the reasons that it's just a nice coincidence that we did this instead is it's a good example of you have to disregard the prefixes. I thought it stated it better. See, this is one of the things when you've been doing this long enough, you actually just apply the rules rather than reading all of them. If you follow maybe like golf, do you read the rule book for golf? You know the rules? Okay. So, for instance, if you tee off and you go out of bounds, what does that typically mean you do? If it's in the rules, you can, but that's more so a course rule rather than a general one. Typically, you got to tee off again. Okay, and then you're hitting what? No, hitting 3. So you teed off, that was 1. You went out of bounds, and you can say 1 more to get off, and you're hitting 3. Or you say it's a 2-stroke penalty, which is the more common way of looking at it. You teed off, and now it's 2 strokes. You're hitting 3 to hit again. Okay, let's say, for instance, you're approaching the green. There's water to 170 yards. The ball goes into the drink, into the water. There's probably a drop zone. So on your second hit, okay, that went into the water. So you hit 2, you get to take a drop there, so that's 3. That means you're hitting 4. Now, that's just a way of explaining things that's a whole lot easier than just reading in the rule book. Would you agree? Okay. So sometimes we apply that to this as well. We've been doing this long enough that we just apply the rules rather than reading every little aspect about that. Okay. Any questions on that compound in naming it? Okay. Are we confused? No, no, and no. Is it better than yesterday? Or maybe yesterday wasn't bad. Okay. Okay. Whatever color you would believe this to be, whether it's teal or light blue or what have you, again, what's the first thing you need to do?
you need to find your paired function,
Parent chain.
which is
Okay.
decade.
Sure. It probably is because it just maybe looks like it. Well, there again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Because what could happen is if this guy wasn't on there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it would be right, but it's not a straight chain, it's a branched type. Does that make sense? Okay, so in this case, this carbon's still here, so it really doesn't matter which way you go. Yes, it's still decane, and we still have how many derivatives on there? There are three derivatives. We've already established our parent chain. It's decane. Okay? So what are our three derivatives? So what are our three derivatives? Well, that's where they're at, but what are they? So again, there's nothing wrong with putting a big E there, an M here, and then an M here. And then when you do that, you tend not to forget to account for all three of them. Okay, so now we need to decipher, is this going to go left to right or right to left? Okay, so, well, in this case, let's look at this. If we go left to right, we've got one on 3, 6, 7, 8. Okay? And if we go the other way, we would have 3, 4, 5, 6, 7, 8. Okay, so do we go by the orange or do we go by the green? Well, the first or the second color? Okay, yeah, this is green. It might look black from where you're at. So 3, 6, and 8, or 3, 5, and 8. So because of this, that's the difference that we would see. Okay? All right. So now the next thing we need to do is put them in alphabetical order. Okay? So we begin with what? Okay? What comes first? E or dimethyl? Because there's two of them. Ethyl does. We established that on our last example. Okay, so we got 8-ethyl. Then what? 3, 5 dash dimethyl decane. You usually put the smaller one first. Yep. Even though you're numbering in this direction, you would still put the smaller number first. Okay. Correct. Yeah. Yep. All right. Can we erase this? All right. So, if we remember from physical science, and chances are we probably do, maybe yes, maybe no, this guy. Where those lines intersect with one another. What's happening where they intersect at each one of these lines? There's a what atom there, do you think? No. There's a carbon atom. Okay? So each line where they intersect, there's a carbon atom. Okay? So what is 7? I just like doing that because it see how well you are at drawing a 7-sided figure. So it's heptane. That's correct. Okay? Now, there has to be something more to it because I think you would agree those are two totally different structures, correct? but we can't call them both heptane. So there must be something on the right that would denote that as a different type of structure. It's a ring structure, so we would call that cycloheptane. You just happen to glance to it at the book, or?
Yeah, it's in the book.
Okay, that's fine. Cycloheptane. So any ring structure, even this, cyclobutane.
It's so cycle.
Yes. It's a geometrical shape. At each intersection, there is a carbon atom. Okay? Name the ring structure for ethane.
Cyclo. No, it's
I asked you to.
not. Cycloethylene.
Is a line a shape? No, it is not. So it has to be 3 or more. Yes. That was a low down dirty trick, wasn't it? Lower than a snake's belly where? No. Even lower than that.
In the dirt.
You're getting closer.
The hole.
No.
But it's right.
Okay, if a car drives through the mud, what does it leave behind? A rut or a wheel track. So, for instance, if this is the ground and the snake is slithering that way, he's just slithering across whichever way they're going. But if there's a rut, well, then they're slithering through here. That's pretty low. That's lower than a snake's belly. This is lower than that. That's where that comes from. It's lower than a snake's belly in a wheel track. It's pretty low. Uh-huh. Learn something every day, don't you? Okay. All right.
All right.
Time to broaden our horizons. We should say pop quiz.
Okay.
Oh, really?
On the marker board. Let's go.
Well, we can't record that because we can't have students on here being filmed. I do believe that's a policy. But we could lower it to where we can hear you, just can't see you.
Oh, you're up there.
You're the one that wanted to do it.
We're broader.
That's all right. Oh my gosh, what? Just because it's the color blue, that doesn't mean anything. Is this a cheer? 4, 5, 6, 7, 8. Okay, so what's the first thing? What do you do first? Which is what? What is it? Decade. I better move him over because we got a few derivatives. Just a straight change, not branched. Yep, there's no proper term for it. Okay, do we have anything branching off of decane? Where's the ethyl group? Okay. Ethyl. about it?
The third one. The 3.
1, 2, 3.
No, the 3.
1, 2, 3.
1, 2, 6.
Okay? C3, remember, this is a carbon-to-carbon bond, not carbon to hydrogen. So the formula for this is C3H what? 7. There's your propyl group like you said. Okay, is there anything else?
You have methyl on 3 and 5.
So we need to have 4 numbers.
So we should have
So now, going left to right, we'll use orange again. So we got at 3, 5, 6, and 7.
so we have 7.
And if we go the other way, then we've got 1, 2, 3, 4, 5, 6, and 8. So do we want 3, 5, 6, and 7, or 4, 5, 8, 6, and 8?
3, 5, 6, 7, 4.
Okay, and the determining factor then would be these two. This gives us a lower combination. You might think, well, I guess there is no other way of looking at it. But let's say these were both starting with a 4. Well, then what would determine it then? No, the alphabetical order of it. If you had, for instance, an ethyl group somewhere other than that was also on the third one, like if you had an ethyl group on here, well, then you, whichever one has the lower number for alphabetizing is which direction you would go. Okay, so we are using the orange, so let's go ahead and get rid of this color. So now your alphabetical order,
7
okay? So 7, we got decanonyl, so 7 dash ethyl, 3, 5 dash dimethyl, like I said, it's always going to take more room than what you think. But I wrote that really big. Okay. The last thing we will do, so we're ready for this tomorrow, and that is, okay, so if you want this name, you have to go back to the video. Okay. So one of the things that, let's say if this is part of the parent chain somewhere, and it keeps going, and remember we say that X marks the spot. If we have this C3H7, that's a what group? If we have C3H7, like I said, this goes on a lot further, so does this. What type of group is this? C3H7. That's propyl. That's not the only propyl group. The last one is this one. Isopropyl. Okay? So, what that means is how many carbons do we still have in an isopropyl group? 3. There's still 3 carbons. Okay? So, the structure is different in isopropyl. What that means is now you've got X marking the spot here, okay? And then it's got a methyl group on both sides of that. The carbon to carbon bond here where it attaches, now there's a methyl group on each side. What is the molecular formula for isopropyl? How many carbons? Okay, just like this for propyl, how many hydrogens are there? There's still 7. So what that means is a propyl group, this is where that X marks the spot. This is propyl, and then where X marks the spot, that is isopropyl. The only way you can determine an isopropyl group is look at the structure. Propyl is a straight chain derivative, where isopropyl is where you have a methyl group on each side of the middle carbon.
But it's still really 7, right?
Yes, but the structure is totally different. All right, so in this case, this is an exception to the rule as well. You utilize the I for alphabetizing in isopropyl. You do not go by the P, you go by the I. Remember when we had these terms, dimethyl and ethyl, right? The E for ethyl comes first because you disregard the prefix di. That is not the case when it comes to isopropyl. You utilize the I in the prefix. Okay, we will catch up to you next time.